Hi everyone and welcome back to Astronomy 10. Today we're going to be exploring the Earth, Moon, and sky. So let's go ahead and start with the Earth and the sky. And the first thing we want to know is how to navigate Earth. So we have here two different depictions of this. We have coordinates that we use in order to navigate our Earth. That way we can get a very specific value of where some destination is or just some places. So here, as we move up the sphere along this line here, this is called latitude. So latitude, you can see on this as well, starts at the equator at 0 degrees at the equator, and then increases as you go towards the North Pole, and that is at 90 degrees. Okay, so that is how we do the latitude portion. Okay, so that would be these lines here going horizontal to count all the way up to the North Pole. Then we can also go below the equator to the South Pole, and that we count in negative values. So you can see here this first value that's marked is negative 30 degrees, then negative 60, all the way to negative 90 at the South Pole. Okay, so this is how we navigate our position on Earth. Then we will also need to navigate the you can call it like the Y position if this was like XY coordinates, right? Something like that. And the other term is called longitude. So on here, we can see on this left picture that we have longitude, and that would be going in the east-west direction. Okay, so this is east-west. Latitude, I should have mentioned, is north-south direction. Okay, so with longitude, we will count all the way around the sphere, the globe, and we start at the prime meridian, and that is somewhere in England approximately. I think it's Greenwich, if I remember correctly. But that's where the prime meridian is, so we call that 0 degrees. And then we go from there longitudinally. So we go 0 to 30 to 60, all the way to 180, which would be directly on the other side of the globe, the other side of Earth. Okay, and then all the way back down. And these go, this is a way to count as well. We have 0, negative 30 degrees, negative 60, so that would be going left or west on the Earth, on the globe. Okay, so this is the first step into understanding how we can do the same sort of thing with the sky. So let's start talking about that. So we have something very similar. This is called right ascension and declination. So imagine just projecting Earth's Earth's what would you call that? The way we navigate on Earth, project that into the sky, and that's what we get here. So instead of latitude and longitude, we now have a right ascension and declination. So right ascension is going to be similar to your longitude. So RA, something like longitude, since it is east-west direction. Okay, so that's going to be along the celestial equator, very similar to on Earth, it's along the equator. And then we have declination or dec, and that's like latitude since it's on the north-south direction. So if we want to, if we look at this right-hand side image over here, we can see Earth in the middle there, then the celestial sphere surrounding it. We have the equator at 0 degrees declination, okay? And then right through the same spot as the prime meridian that we just saw on Earth, that's going to be where we have the right ascension is 0 hours, okay? So note one thing, declination is in degrees and right ascension is in hours, minutes, and seconds, okay? So the reason the right ascension is in hours, minutes, and seconds is because that is how we tell time. So it takes 24 hours for the Earth to rotate. Therefore, we use this to tell our time. Okay, so there will be 24 hours of right ascension all the way around the equator here. Okay. All right. And then if we're looking at a star, so again, how we find the stars on like a star map or a celestial sphere, we can say this is, let's see, we can say 1, 2, 3, 4, 5, whatever this may be. It may be hours. These might be in 2 hours at a time. I'd have to sit here and count them. But this would be some amount of hours, and then we'd go up declination. So that would be like 30 degrees, or actually 15, 30, 45, a little above 45 degrees, and that would be our declination of that star. So you would say the star is at, and then you'd give the right ascension and the declination. Okay. All right. So let's move on to Earth's motion. Okay, there are two different ways that the Earth moves. Okay, it rotates about its axis where we have some axial tilt. Okay, and that's about 23 degrees, 23 point, I'm not sure, about 23 degrees. And then the planet will rotate about that axis. As you can see here, go ahead and circle it. That's where we have the rotation. So this is rotation. Okay. Now we also have the direction of orbit. So we have the rotation, which this is going to be a daily occurrence, right? It takes 24 hours. Whoops. It takes 24 hours. Or 1 day for one rotation. Okay. So we, for one whole day, it's 24 hours. Okay. Then over here, we also have that the Earth orbits the sun, right? So Earth orbits the sun, and that takes 1 year, or about 365 days. Okay, and so that is for one orbit around the sun. Okay, so as the Earth moves around, we have two different motions. We have rotation and then we have orbiting. Okay, so note which one means what, and what that motion looks like in a diagram. Okay, and we'll get a bit more into that in a minute. But this is the basic um, idea of Earth's motion. Okay. One thing I should point out is this axial tilt gives us some sort of tilt from the ecliptic. Okay, so we have the ecliptic, and that is the path that the sun apparently makes in our sky. That's what we see, but that's really where Earth is moving, okay, along that ecliptic. And it is off from the celestial equator here by some degree. Okay, so just make note of that. I drew those lines in the wrong spot. Here, between those two. Okay. All right, it's kind of like just taking the Earth and then shifting it just a little bit to be on some tilt. Okay. All right, now with that tilt, 23.5 degrees. The reason we have seasons is because of this tilt exactly. So let's start in December, since that is basically around what we're in right now. We're in winter time. So in the winter, our sun is putting sun rays. I need a different color. Hold on. It's not going to work. Maybe yellow. The sun will give us a lot of sunlight, but a lot of it is going to be in the southern hemisphere. Okay, so if you see that on the Earth here, this is approximately the equator. Okay, just cutting the Earth in half. We get a little bit of sun up here in the North Pole, all this area, but a lot more in the South Pole. Okay, so in the winter, the northern hemisphere, sorry for the bad handwriting, um, the northern hemisphere gets less sunlight. During the winter time. Therefore, it's typically colder, right? And that's why we've got winter here in the northern hemisphere is cold, okay? But if we're looking at the southern hemisphere, whoops, the southern hemisphere gets more sun, more sunlight, so it's warmer. So their winters are warm, okay? So that's the difference between the northern hemisphere and southern hemisphere at that time of year. Now let's go to the complete opposite side. Let's go to the summer. Okay. That didn't look perfect. Give me a second here. Okay. Now in the summer, we're again getting sunlight onto Earth. But in the northern hemisphere, Now we're getting a lot more sunlight. So northern hemisphere gets more sunlight, so it's typically warmer. So we have warmer summers, which makes sense, right? Here in California, especially in the Central Valley, it gets very, very hot in the summer, right? We get a lot more time where the sun is out, and so we're getting a lot more sunlight versus the southern hemisphere gets less. So therefore, oops, it's colder. Okay. Now, these are the two extremes, but we can also look at the equinoxes. So we've got the vernal equinox, which is like springtime. Just going to write that somewhere around springtime, and the autumnal equinox, which is around fall. Okay, or autumn. Okay, I spelled that wrong. Whoops. Autumn. Okay, I didn't go to school for spelling, I swear. All right. So these two, we have kind of an in-between, those two. So we get, I want to say, kind of like an equal amount of sunlight anywhere in the hemisphere. That's the idea, because that's the change from the winter to the summer and the summer to the winter. So it's that transition period. Okay. All right. And we can see this in these images as well. So we have the sun's path here. This is the sun, and this is the path it's taking in our sky. Okay, this is our horizon from wherever we are. Okay, and this is showing our north celestial pole, wherever that may be in our sky. Okay, so during the day, in June, this is summer, right, for us. This is where we have warmer weather. I'll put that. So we have quite a bit of time where the sun is in the sky. Okay, there is a little bit of time here where it's not, but not a ton. We have a lot of time that the sun is in our sky. Okay, and this, I should say, northern hemisphere. For all of this. Okay. Now, if we look in between, where we have our solstices, where we have March and September, we have kind of an in-between amount of sunlight. So it's not a long time, but it's not just a little bit of time. It's kind of like half and half. Okay. So we've got some amount of sunlight in the sky, but not all of it. There is quite a bit still here below our horizon where we wouldn't, whoops, oh shoot, where we wouldn't see. Okay. Then if we go into the winter time, or around December 21st, this is going to be colder. So cold. Okay. We only have a little bit of time. The sun is in our sky. Okay. And then we have a lot of time where it's not. So we only get a little bit of sunlight around December 21st. Okay. All right. So this is another depiction of this, depending on your latitude and time of year, where we are in our orbit. I should say that here. Time of year where Earth is in its orbit. Okay, so we're going to again look at the extremes. So this is summer and winter. The sunlight will be hitting quite a bit of the northern hemisphere during the summer, around June 21st. Okay, and then for in the winter, it's going to be hitting mostly the southern hemisphere here around December 21st. Okay, and it shows you kind of where we live. So we live here in California, somewhere around right here. Whoops. Okay, so we're going to be getting quite a bit of sunlight here. And then during the winter, we're not going to get as much direct sunlight. Okay. All right. And with all of that information, ancient astronomers or a lot of other people were trying to figure out a calendar. Okay. And they were able to, but some of the reasons why they did this, I think I talked about them before, but one thing was navigation, right? It was important to be able to navigate your way around. Another thing would be for crops or agriculture. Okay, so different crops will grow better in certain times of the year. I don't know a ton about that personally because I am not good at even keeping succulents alive, but a lot of people, they had to rely on this. So we needed to keep track of the time of year. So I need to keep track of time of year and even the time of day to make sure that their crops stay alive and flourish. Okay, so those are a couple of really important things why we started to come up with ways to keep track of time. Okay, the Stonehenge is a really good example of an early calendar. It was used to keep track of the motions of the sun and the moon. Okay, and you can feel free to look into that a bit more, but I just thought it was kind of interesting. And here are some of the known values. So the rotation period of a day on Earth, I'm sorry, the rotation period of Earth is 1 day, okay, or 24 hours approximately. The month is based on the time for the moon to complete its cycle of phases, and we'll talk about that in a minute here, or maybe in the next video. And that is 29.5306 days. Very specific, but about 29 days. And then the tropical year, which is the period of revolution of Earth around the sun, or the orbital period, and that is 365.2422 days. Okay, again, very specific, approximately 365 and a quarter days, and that's why we have leap years. If you want to look into that, I don't think I will have time to do that. Okay, so this is approximately how they defined these different things. So we've got the day, we have month, and then year. Okay. All right. Okay, so this is where I'm going to pause, and then we'll pick up in the next video.